Okay, ladies, today I'm going to demonstrate how to solve a classical mechanics problem about a mass on a spring. So a block with a mass of 2 kilograms is attached to a spring. The constant of the spring is 8 newtons per meter. At t equals 0, hurry up, move the camera, buddy. What am I doing here? It is at equilibrium at rest. A time-dependent external force acts on it. Force external as a function of time equals 12 newtons. Ignore all friction. The question asks, find velocity of the block as a function of time. So the first step is going to be, write that down. First step is going to be start with Newton's second law. What am I doing here? Write it down. Newton's second law, which is force equals mass times acceleration. Now we gotta convert that to a form that fits this problem, which is net force equals, write that down, buddy. Yeah, write it down. What the hell am I doing? Net force equals external force minus kx. And k is obviously the constant of a spring. Constant of a spring is how much force is needed to condense or expand the string. X means position. Now what I'm doing is plugging in values. What am I doing? Okay, I forgot what mass times dv over dt derivative. I forgot what that was. Okay, anyway, we're just plugging values to the equation. Look at the example first if you want the values again. 12t minus 8t all come from the question. But velocity equals dx over dt, which makes this entire question way harder. So we have to reevaluate and first find acceleration from force. Okay, what am I doing here? I think I'm just thinking it over. Okay, now, I'm trying to memorize the equation. I'm trying to formulate it, right? Okay, acceleration as a function of time equals, should be external force is a function of time over mass. Over mass. What am I doing? Over mass. Okay, and then write no, don't write that. Just notice that we're going to ignore the spring for now. Now you just gotta plug in values. 12t over 2 equals 6t. Acceleration is 6t. There we go. Now we have to find velocity, and to do that we're going to integrate both sides. Step 2, that's a horrible 2. Step 2 is to find velocity. To do that we're going to integrate both sides of the equation. Acceleration as a function of time equals, let me write that down first. Acceleration as a function of time equals dv. What am I doing? Oh no, I'm just rewriting. Okay. Just wait for me to finish doing that. That's going to turn into velocity. Oh, okay, no. We're just integrating first. I'm not that good at integrating stuff on my own. I would have used a calculator here, but I didn't have one, so I just raw dogged it. Can you just, like, speed it up, bro? What the hell am I doing, man? Why am I so slow? I actually recorded this video, like, an hour before I started voice recording right now. Okay, anyway. Velocity. Oh my god. Is my pen dried out? No, it can't be, right? Yeah, okay. Velocity as a function of time equals t squared oh yeah, okay, because we're going to simplify it. T squared over 2. Now we have to I forgot to write the constant of c. I always forget to do that when I'm integrating stuff. Always forget to write the constant of c. Anyway, simplify that. You should get 3. I mean 3t squared. Yeah? What are you doing? What the hell am I doing? 3t okay, good. 3t squared plus c. Then now you have to remember at t equals 0, the block is going to be at rest. Okay, now we know that velocity as a function of time is equal to 3t squared meters per second. That is our final answer, but we gotta confirm that it's a true answer, so it's the true answer. So step 3 is to check the derivative. I think I was explaining in the recording. The voiceover is better anyway. dv over dt equals d over dt. 3t squared. 3t and squared. That's going to equal 6t. I'm pretty sure. 6t equals 6t. Okay. Yes, equals 6t. Stop thinking about it, man. Okay, and that exactly matches whatever we wrote before. That matches our, what was it? That matches our acceleration. Therefore, our final answer is going to be, what am I doing? Oh. Yeah, final answer is going to be velocity as a function of time equals, right here. We're supposed to find velocity as a function of time. That's what the question's asking for. So our final answer is going to be velocity equals 3. It's really hard to write on that, trust me. 3t squared meters per second. That's our final answer. What I decided to do is write the acceleration under that because it's a little side step that we calculated along the way. So you could do that if you want. Yeah, I think I'm explaining in the video, and that's how you solve massive spring problems.